And our first speaker is Dr. Lu Jun from the China Satellite Navigation Project Center. So she is the deputy director of this institution, and her research is focused on time and frequency technology of satellite systems and GNSS compatibility and interoperability. Dr. Lu. Okay, the floor is yours.
Okay, Chair, thank you. Can you see the shared screen?
Yes, it's perfect.
Okay, thank you. Thanks, Chair, and thanks, Professor Zhao. I'm Lu Jun from China Satellite Navigation Project Center. Good evening, everyone. Nice to meet you in this teleconference. My presentation is about BDS PPP featured service on GEO B2b signal. My presentation divided into 4 parts. We know that before Constellation of BDS was officially put into service on July 31st to provide diversified services. As to global services, it includes PNT, global short message communication, international search and rescue services. As to regional services, it includes SBAS, ground augmentation service, PP, and regional short message communication. You can see that among these 7 services, 4 related to PNT. The real-time PPP service is newly provided by BDS. The correction parameters, including satellite weight, clock offset, and DSB corrections, are transmitted by B2b signal from BDS view satellites. In July 2020, the ICD document was released. In May last year, the BDO service performance standards was released. Currently, users can get decimeter kinematically and centimeter statically in China and the surrounding areas. Second part is PPP-B2b product. Satellite-based real-time PPP has been widely used in offshore oil drilling platforms, survey ships, and desert exploration, etc. And mature commercial services has been already by most commercial companies. Users need to buy dedicated receivers to get corresponding services. And also, at the same time, meanwhile, BDS can provide PPP-B2b service to China and the surrounding area. Compared to commercial services, it is free and embedded. BDS GEO satellites broadcast B2b message by I component. Each message has a length of 486 bits, including the highest 6 bits of message type and the lowest 24 bits of CRC, and the remaining 456 bits for message data. And its specific contents vary depending on the content type. The broadcast time of each frame is 1 second. Here shows the message type. We can see the message type distinguishes from different information content. And the clock corrections are broadcast every 6 seconds, while the other messages, including the orbit correction, the DSB, are updated every 48 seconds. So if we want to select the whole complete message, we need 48 seconds. Here shows the B2b procedure. The ground monitoring stations collect observation data and perform processing on server side, and corrections are injected into GEO satellites and broadcast, and users using certain algorithms to get the PPP service. Here shows the user algorithms. For DSB, for orbit correction or clock offset. And there are some points that need to be pay more attention. The orbit term is a tender reference point, and the clock term is also on B3I. Second part is performance assessment. Okay, here we define a EAR, this figure, to define the ratio of the length of the observation sub-arcs with available PPP-B2b corrections to the length of the total observations arcs. We can see the left figure that in China, the EAR is better than 80%, and the maximum is 95%, and it drops when it moves away from China. And the right figure is about the average number of visible satellites. In China, at least 7 satellites with available corrections can be received. That is guaranteed. Here shows the assessment strategy. We collect the data, we collect the product from the time span since August 1st, 2020 to May 1st, 2021, and using PPM product as a reference to assessment and analyze the orbit, clock, and SISRE, and the assessment methods are showing on the slide. Here shows the assessment result of a PPP-B2b orbit. You can see that the BDS and the GPS orbit, the IMS is at a 10 centimeter level. You can see almost radical cross and cross just at a 10 centimeter level. And compared, the product is IGS product, Lucy and CNES. Here shows the assessment result of a PPP-B2b clock. You can see that the results, the BDS GPS clock IMS is nanosecond level, and the clock STD is better than 0.3 nanoseconds. That means sub-nanosecond level. And here shows the SISRE assessment result. You can see the B2B, the STD SIRE is better. The result is 3 centimeter, 3.9 centimeter. It is resulted from the using measurement data of intersatellite link. And we can see other dot for IMS and STD of B2B is about maybe IMS is centimeter and meter level respectively, and STD better than 7 centimeters. Here shows the data collection and the PPP strategy. Also new time span and using the station's monitoring results. Here shows the PPP strategy. As to the static mode, we using a GPM product as reference for post-processing mode. Also horizontally and vertically, the IMS for BDS only and also BDS plus GPS is better than 3 centimeters. And compared to BDS only, BDS plus GPS horizontally improve almost 16%, and vertically improve almost 23%. Kinematic mode, you can see using also the GPM products as a reference, and horizontal and vertical IMS of BDS only is about 22 and 33 centimeters, and BDS and plus GPS is about 15 and 33 centimeters. Here shows the convergency time. The convergence time for BDS only is about 17 minutes. And for BDS plus PPS is about 16 minutes. So it's better than the performance standards that are published last year. We also carry on vehicle experiment using RTK and RTK as a conference. And the antennas was mounted on the top of the vehicle, and the environment is open and unobstructed. And the data was collected by the receiver and transported to PC according to the positioning accuracy and convergence time in accordance with the proposed accuracy and the convergence time in BDS open service performance standards. And the result is good. Also, we conducted smart terminal positioning test. The smart terminal single frequency PPP is about 1 meter. So maybe in future, in mass market, benefited from BDS PPP service. Mass market users can receive almost 1 meter level accuracy. Let's conclude my presentation. As to EAR, in China, the availability is better than 80%, and the maximum is up to 25%. And for orbit accuracy, IMS is at decimeter level. For clock, IMS and stand STD is about a nanosecond and sub-nanosecond level. For SIS-RE, IMS is a meter and meter level. STD is better than 7 centimeters. So BDS3 PPP accuracy is 30 centimeter level and kinematic centimeter level. The results achieve the service accuracy in BDS open service performance standards. And we think in the future, the service will be also optimized to for better accuracy, for wider service area, for more global navigation system supported, and also better convergence time. And also maybe benefit from these high accuracy services. More applications are as expected, including expanding from professional field to mass consumption field. Okay, that's all. Thank you.
All right. Thank you, Dr. Lu. I think this is a very great talk. And Dr. Lu has saved a lot of time for us. So any questions from the audience? Hey, Leo, I think that the audience can type the question in the chat box, right? Or they can just open their mic to talk.
Yes.
I don't know which way is better.
Please feel free to either use the chat and we'll read it carefully. You can also use the raise your hand action in the reaction at the bottom of the screen, and we'll give you the opportunity to talk.
Okay, any question from the audience? I think we need some time to warm. Okay, all right. So we have a question from AIUB group. So what did happen on the plot on page 23 at about 8 o'clock? Could you turn to page 23, Dr. Lu? Is it really 23? At 8 o'clock, you have some problem where the noise of your kinematic solution was heavily reduced. Could you see the chat box? I don't know which, is it really 23? 20.
Not 23. 23 is
I say 22.
part. Oh, okay.
22.
Okay.
So at 8 o'clock, 22. This is 18.
Was the last slide with here?
Yes, this one. So you have 8 o'clock, right? 8 o'clock. Is it 8 o'clock or?
somewhere.
Is it really 8 o'clock? I think 8 o'clock is fine, right?
Okay, which moment?
People from AIUB,
Yeah.
maybe you can comment. I do see a small drop at 8 a.m. I suppose, just before noon, but
It's at the end of the night somehow at 6 you have a different characteristics of the noise.
Okay,
Now north south it's really going much closer to 0, and the pattern in the up component in the lowest does change. So from this, it's a question whether there is an event or whether it's just by chance.
okay, here so the result is about a single frequency, not just according to the standard performance. It's a 12 frequency. Here shows a single frequency. So this accuracy is not better than 12 frequency or multi-frequency. And also it is a kinematic mode, mode. And maybe according to the signal quality that received from smart terminals, maybe the quality is not good as our BNSS receivers. And also according to the constraints, the epoch wise not with their constraints. Am I clear?
Okay, thank you.
Okay, thank you. I think so. Okay, thank you, Dr. Lu.